Hello, geometry students. Mr. Zacek back and better than ever. And we are going to be talking today about how do we prove triangles similar. And so, just right from the start, we want to think that we want to differentiate this from congruent. So, when we think about similar, we're thinking about this notation. Looks like this. And we're going to talk today about three methods to prove similar. In our last lesson, we said that when things are similar, what we want to connect with the idea of similar, whoops, moving the wrong thing, is we first want to connect that we have congruent corresponding angles, and we want to think that also proportional sides. And so in our last lesson, we were looking at like having to show all of that, but what we're going to learn is that the burden of proof is actually a little less. And we're going to start right off with the first one, and this by far and above is the most common one that you're going to see. So if you don't remember all three of them, you definitely want to remember this one. It's if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So if we can prove that two angles are congruent, and so this would be a statement, and the reason would be angle, angle, similarity, postulate. Okay, so if two of the angles are congruent, the third one's going to be congruent because they all add up to 180, but we don't have to show that. Okay, now here's where we have to kind of differentiate from congruence, proving congruent. This is the side angle side similarity theorem. Okay, and this is how we can abbreviate that, side angle side similarity. Well, obviously, we're not proving congruent, but what we're showing here is, first of all, we have these proportional sides, and we have the congruent included angle. All right, so it has to be the included angle. So if we can show that these are the equal ratios, and we can show that the angle between them, angle A and angle Q, then we could say that those triangles are similar by side angle side similarity. And then the last one method is side 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 similarity. And so in here, again, we're not showing congruent, but we're showing that three sides are proportional, meaning their ratios are all equal. And we can make that statement, and that would be side 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 similarity. Okay, so again, just to summarize, so our three methods to prove similar, again, one is angle angle similarity, two is side angle side similarity, and our third reason is side 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 similarity. So if two triangles are similar, then we know their corresponding sides are proportional and their corresponding angles are congruent. Okay, so this is the kind of stuff that can follow once we prove similar. All right, is that we'll have proportional sides. Okay, whoops. Somehow my board got a little off here, but let's see if we can move it on. Okay, so related to that, kind of a corollary is if two triangles are similar, the lengths of corresponding altitudes, corresponding medians, corresponding angle bisectors, and perimeters have the same ratio as the lengths of any two corresponding sides. So if we're looking at this here as an example, this particular portion, so AB, all right, is going to be similar to XY, all right, those are the corresponding, and then BD is going to be similar to YW, meaning they're in the same ratio. Okay, in this case, those are, let me get my pen back. Pen, come back. Those are altitudes. Okay. All right. So, and that would also be true for medians, angle bisectors, perimeter. All right. Are the two triangles similar? All right. And how do we know? So let's again keep in mind our three methods: angle-angle similarity, side-angle-side similarity, side-side-side similarity. Okay. So we're looking for one of those. Well, we're given that these angles here, and we see the freebies would be our vertical angles. And so the answer would be that yes, and the reason would be by angle-angle similarity. Okay. So in this example in B now, we've got to do a little bit of work here to figure this out, because this one looks like it's kind of set up by possibly side angle side, but we need to find the included angle. All right, so find the included angle. So this is an isosceles triangle, so this is going to be 68, and 68 plus 68 adds together to be 136, and 180 minus 136 is going to be 44. All right, so while the sides, those two sides would be in proportion, it would be no, because the included angles are not equal or congruent. So in that case, we would need those the angles to be the same, and they're not in this instance. Okay, are the triangles similar? If so, write a similarity statement for these triangles. So here we're given the side, so possibly we could use side, side, side as a reason. So here's what I like to do. I like to write out these, and I like to pick one of the triangles, and I'll just kind of get a highlighter here. I'll start with this one, and I'm going to put all of those in the numerator. So I'll go 6, 8, 10. Okay, now what would correspond with 6? Well, that would be 9 would correspond with 6, and then 12 would correspond with 8, and then 15 would correspond with 10. And again, we're asking the question, are all these equal? So let's reduce it. 2/3, 2/3, 2/3. So therefore, we could say that triangle, let's go with SUT, is similar to triangle. So if we started with S, S would correspond with X, W, V, and the reason would be by side, side, side similarity. Okay. Now, we start to get slightly more complex here in B, because we have two overlapping triangles. So let's remember that whenever we have overlapping triangles, one of the recommended strategies that we've shared is draw these things separately. So we got L, K, and P, and then the bigger triangle would be M, N, P. So the first thing we want to notice is that, what did I write P? K. Should be K down here. Is that angle K is congruent to itself because it's the same angle. And so we have 8 and 12. And then we have, if we add 8 plus 2, we'd get 10 and 15. So the included angles between those two sides, included angles, are congruent, okay, by the reflexive property. So the question is, are those sides proportional? So we do 8, board's getting a little crazy. 8 and 12, 8 corresponds with 10, 12 corresponds with 15. So this is a question mark right now. Are these two things equal? So this reduces to be 4/5, and 12 and 15, 3 goes into each of those, 4/5. So therefore, okay, so we could say that triangle, let's call the first one LKP, is going to be similar to triangle MPN, and this one would be by side angle side similarity. So again, the included angle is congruent, and then the sides that form that included angle are in the same proportion to each other. Okay, so we're going to turn to our next page here now, and then we've got an example and some proofs. A little hard to look at, but before rock climbing, Darius wants to know how high he will climb the cliff in the mirror. What is the height of the cliff to the nearest foot? So this is if you see in the picture here, this is an angle here and an angle here, and they've got congruent, and then of course they're both perpendicular. So what we're trying to, the property we're using here is that the triangles are similar, therefore proportional. Okay, that's the thinking, the kind of the mathematical thinking that we want to have related to this. So, so 5.5 is his height, and 6 is his distance from the mirror, and 6 is going to correspond with 34, and then the height, which we're going to call x, is what we're going to try and find here. So we'll put that up on, or x below the 5.5. So we're going to use our cross product property. We're going to get 6x equals, and then we go ahead and do 34 times 5.5, which is 187. And then we divide that by 6. Okay, and so we're going to get 31.16 repeating feet. So when it says to the nearest foot, this is approximately 31 feet would be the height of it. Okay, and that's a, it's kind of a tool that you could use if you had to approximate maybe a tree in your backyard. I had to do that one time. We had a pole, we had to change a light, and the electrician had 2 different sized bucket trucks. So we needed to kind of approximate how high it was in order to get there. Okay, let's get into the proofs, and this first one is going to be common here, and so we'll talk through it here. And this type of thing that you're being asked to prove, this is kind of a similarity proof. Now, it may not be as obvious to you initially, but so let me walk you through what we're going to do with this similarity proof. So number one is, I'm going to say that MP is parallel to AC, and that's given. Now, you want to think with parallel angles. You're looking for congruent angles, and in this case, angle A and angle P and angle C and angle M, those are alternate interior angles. So that's what we can say as a result of that. Angle A would be congruent to angle C, excuse me, not angle C. Angle A would be congruent to angle P, and angle C would be congruent to angle M. All right, and that's from the fact that they're parallel. So if 2 lines are cut by a transversal and parallel, okay, so transversal and parallel, then alternate interior angles are congruent. Okay, so now that's enough to prove that the triangles are similar. I know somebody's sitting there and say, hey, couldn't we do vertical angles? We could, but we've already shown 2 angle pairs in this one, so we don't need to do more. We've got enough here. So we have triangle, I'll call this one ABC, similar to triangle. Now when I look at this, notice how A has the 1 mark and B is in here. So I'm going to go PBM to make sure I write this similarity statement correctly. PBM. Okay, and that's the reason that we just talked about, which is the angle-angle similarity postulate. Okay, I apologize that my board is just being very uncooperative at the moment. Okay, now this is kind of like CPCTC. That's kind of like the thinking that you can have when you see this proof. And I want to show you how I think about it. I'm going to start with the last step actually, which is CB times PB equals AB times MB. Okay, now what this is for us here, well, we'll get there, is this is called, whoops, oh, I don't like when the pen doesn't want to work for me. This is called the cross product property. And I know I'm skipping a step, but I want to show you how to think about this. Okay, cross product property. CROSS, crazy pen, doing crazier things. So here's how I go. I kind of work backwards when I do these questions. In a proportion, we multiply the things that are across from each other. So CB and PB, that's what's going to be multiplied together, and AB and MB are going to be multiplied by each other. So I look kind of at the final step and I work back to set up the proportion. Now, why can we set up a proportion? It's this. When two triangles are similar, their sides are proportional. And then once we create the proportion, we do the cross product property, CB times PB equals AB times MB by the cross product property, which is the product of the means equals the product of the extremes. Some people write all of that out. It's the product of the means equals the product of the extremes. It's the cross product property. You can write it either way, okay? So I think we've got another one that's like that one. So I want to do that one. Let's go ahead and do number 6. We'll kind of skip number 5 here in this example. That's going to be an angle reason. But so again, here's what we're given in the accompanying diagram. This and this are parallel, and AC intersects at point T. And again, we're trying to prove this. So what we just sort of learned is that proving that means we got to go do the cross product property, but we first have to prove that the triangles are similar. So it's a little bit of backwards thinking, if you will, kind of starting with what we're trying to prove and then working our way backwards. This is almost going to be like the exact same proof as we did last time. So you might want to pause this and just try it out yourself. So WA is parallel to CH, given, okay? So I'm just going to go ahead and do it the same way. I'm going to do W and H. I'm going to do A and C. Okay, again, we could do vertical angles. That's completely acceptable. So angle W is congruent to angle H. Angle A is congruent to angle C. And the reason is if two lines cut by a transversal, two lines are cut by a transversal and parallel, then the alternate interior angles are congruent. Seeing on a lot of people's paper at times, they're not having the 3 components of that reason. It doesn't have to be worded exactly that way, but you need to have transversal, parallel, and angles, okay? So a lot of people are just writing like alternate interior angles are congruent. That's not enough. Okay, so now we can say that triangle WTA is similar to triangle. If I started with W, I should start with HTA. And the reason with that is angle-angle similarity postulate. Here's where my board starts going nuts on me again. All right, now again, I like to go and kind of work backwards on this, so I'll just show you how I do it. I like to do the last step, WT times CT. So in my proportion, I know that WT and CT need to be opposite each other, or on the diagonals, and then HT and AT, so that will be the extremes. Okay, so again, when two triangles are similar, their sides, their corresponding sides are proportional. So when two triangles are similar, their corresponding sides are proportional. And then the last one is the cross product property. It's the product of the means equals the product of the extremes. It's the cross product property. So in these proofs, like 90% of the time, the reason is angle-angle as we're doing those. Okay, so there you have it. Triangle similarity proofs, not as extensive as congruent. There's not like, hey, there's other reasons we haven't talked about them. That is the scope of it. But then this kind of, those extra two bonus steps, that's often where it shows up. Okay, so good luck with this. Let's keep on asking questions, and I'll see you soon.